rational expressions. So we just simplified, we added and subtracted, we multiplied and divided, and now we're solving. So the first time your directions will say solve, and for the first time you will see an equal sign like this. And technically, because there are no x's in the denominator, we have done this problem before this semester. So I will remind you that when you have an equal sign and you have fractions, you can cancel those. All you have to do is pick the least common denominator, which in this case is 6, and multiply every single term by 6. Now if you choose, if you don't have multicolors like I'm using red, you might stick them in a box. Something that just reminds you that you're putting that into the problem. It didn't start like that. And then reduce. And if you pick the correct common denominator, you will no longer have fractions. Right here I have 3, and right here, oh, do you know what? This is supposed to be a 3. I was thinking those were different for some reason, and that's supposed to be a 2. So I apologize. Fix that in your notes. That's a 3. So when I reduce that, this will be a 2. So I have now 2 times the x that's there. And then, since I have 3 over here, I'll go ahead and subtract 5x from both sides. So if I subtract 5x, I now have negative 3x. And then we'll divide by negative 3, and we'll get negative 1. And that's your answer. You're done. The only thing that you have to worry about with rational expressions, equations, is that if you plug negative 1 in, it won't make any denominator 0. Now we can see the only place to plug it in is in the numerator, right here and here. So we don't have to worry. We know it's a solution. And I'll show you in the minus 3 equals 2 times x plus 1 all over x minus 3. I have an equal sign, so I can get rid of my fractions. I just have to find the least common denominator. And this one's kind of easy because they're the same, so I know the least common denominator is x minus 3. So I just multiply every single term by x minus 3, and it cancels every single fraction. So we have x plus 5 equals 2x plus 2. Now, I'll go ahead and take x to this side. So I'm going to subtract 2x from both sides. So I have now negative 1x. And in that same step, let's go ahead and subtract 5 from both sides. So I have negative 3. And that means I have to go one more step and divide by a negative so that I have positive x equals positive 3. Now you want to circle it and say you're done, but guess what? If you put that in for x, look what it does. We have 3 minus 3, and so we have 0 right there. And so this term is undefined. So I don't know if it equals this side, because if it makes it undefined, we can't tell. So this is no solution. Now sometimes you'll have a couple answers, and one might work and one won't. So be careful on those. 2 over x plus 3 minus 1 over x squared minus 9 equals 1 over... Here, I just had a simple constant, a number that I could pick, the smallest thing they'll go into. Here, they were the same, so it was easy. But now I have different factors, and here I have an x squared, which tells me I should begin by factoring that. So I'm going to factor that, and now I can see that the smallest thing that they'll all go into would be both of those. So my least common denominator is both x minus 3 and x plus 3. So just like before, I'm going to multiply every single term by x minus 3, x plus 3, x minus 3, x plus 3. Remember that terms are separated by plus or minus signs, and that you have to do it on both sides of the equal sign. So here the x plus 3 cancels, here they both cancel, and here x minus 3. So now, and then this is a big point of error, is we have to distribute that negative, but in this case I have nothing to distribute it through, so that one won't cause an error, x plus 3. Alright, let's just combine like terms. So I have minus 7 equals x plus 3, And then, since we just have x, let's get x alone. So I'll subtract x from both sides, and I get 1x. And in that same step, let's go ahead and add 7 to the other side. So I get 10. Now, if you plug 10 in, you get 13, you get 91, and again, 7. So it doesn't cause anything to be undefined. So it is the solution. Alright, let's try this one. Oops, that's a Z. I do need glasses. I've got to start wearing because I can't tell between a Z and a 2. Alright, now once again this is like this one. I can't see my common denominator until it's factored. So I'm going to begin by factoring, and here there's just 2 terms. So all I can do is pull out the common factor, pulling out a Z. Can't simplify that one. This one will factor into 2 binomials, and this is kind of a cheat, but since I see this factor, I'm going to check and just hope that it will be one of these. So if it is, let's see, to make 3z squared, I just need to times it by 1z, right? 1z times 3z is 3z squared. And then to make 6, I need to have 2 times 3. So 2 times 3 is 6. And to be negative, this would be, but to make sure, because that might not be one of the factors, let's FOIL it and check it. So outside times the outside is negative 2z. And inside times the inside is positive 9z. And aha, they will add up to my middle term, my 7z. Hope you can read that, crazy z. Alright, so now I can look at all my factors and pick my least common denominator. And in this case, we have to include this z, single term, by all. So this term as well, z times z plus 3 times 3z minus 2. This one, z times z plus 3 times 3z minus 2. Alright, so carefully reducing, my z plus 3 is gone, my 3z minus 2 is gone. Here, just my z is gone. Here, z is gone, and 3z minus 2 is gone. So, this term's not too mean, it just is 3z times z, so 3z squared. Now here, this negative is a big point of error. Don't let it make don't cause it to make you make a mistake. I need to distribute that through the whole numerator. So what I'm going to do is I'm going to go ahead and FOIL those first. I'll take z plus 3 and 3z minus 2, and then I'll distribute that negative through. Now on the right side, it's not quite as bad. The z canceled, so all I have is 4 times z plus 3. So I have 4z plus 12. Alright. So, going ahead and foiling, I would have let's just FOIL it really quick up here. I'll put 3z squared, outside times the outside, minus 2z, inside times the inside, plus 9z, and last times the last, minus 6. So now let's distribute our negative. So I've got minus now 3z squared. And right here I have 7 of those. And so if I distribute the negative, I now have negative 7z. And I have negative 6, so if I distribute the negative, I have plus 6. And we still have that equal to 4z plus 12. Now what happens to our z squareds? They cancel, don't they? 3z squared subtract 3z squared, gone. So without a z squared, I'm not going to factor, so all I have to do is get z alone. So let's say I subtract, well, you know what, let's go ahead and add 7z to both sides, just because that'll make our z positive. So I've got 11z over here, and in that same step, let's go ahead and subtract 12 from both sides. So we get z equals negative 6/11. And of course, that can be written like that or like that, right? I can make sure. And if I look up here, I can see that 0 would make it undefined. I can see that negative 3 would make it undefined. And for this factor, 2/3 would make it undefined. So, because that's not 0, negative 3, or 2/3, I know it's a solution. Not cancel out. I would factor it, and I would have two answers. And that's what I mean when I say sometimes one will work and one will make it undefined. So check those answers. I think this section is the best one in chapter 6. I think it's much easier than simplifying, adding and subtracting. So, and this, by the way, is on every exam. It'll be on every test you have from now to the end of the semester. So, very important section. Learn it well. Good luck, you guys.